Good evening, everyone. I think I'm audible.
Yes, sir.
Great. So finally, we are into the concluding session of our workshop, Fundamentals of Digital VLSI Design. Uh, in this particular session, I am very less interested to speak, and I want you people to speak. But before we all can start discussion on what we have studied so far, let's go for a brief recap that what we were doing during these days. So, I am Ashish and I am your learning partner in this workshop. What is today's session's agenda? What we are supposed to do today? We will see that a concise summary of what we have done in our recent days, and then we'll look forward that what was a toolkit that we have used and what toolkit we want to take forward. What is the road ahead? Whatever we have studied, whatever is available to you in your YouTube lectures or anything that you tried to learn in this workshop. So we'll look forward that we'll try that uh, this doesn't stop here and we keep on studying the further things. This is the last thing will be collaboration pathways, that whether you are in a BTech, whether you are in MTech or in the PhD, what are the research opportunities we have, how I can remain connected with you and how I want you to remain connected with me, so that we all can work together and can contain a few things in our CV, can add on something that can actually add up to our upcoming interviews or whatever you wish to achieve through this VLSI domain. So this is our today's agenda. Let's move to what we studied so far. We'll go for a brief recap. In this, we'll see that initially we started we started the device physics, and in this device physics, uh, we understood the silicon. And anything, if you want to do anything about this VLSI, you need to study the basics of silicon, this basics of MOSFET. So what you need to study? You need to study MOSFET structure, fundamental operations, understanding the conduction channel formation behavior, how your MOSFET behaves in cutoff, linear, and saturation mode, and what is the concept of threshold voltage. I want to add on, if you are into digital, that you work with the capacitance. That is more prominently called MOSFET capacitance. This is something that you need to add on. And when you'll go for the advanced topics, you will go for short channel effects. Then you may look for what will happen, what are the impact of these short channel effect as a leakage currents. So these are a few topics that you should always study before you wish to go for any interview or anything which is related to the semiconductors. That will be very much required. What are the books prescribed for this? There is a book of CMOS digital design, CMOS VLSI design with Kang and Leblancc. And then I'll ask you to study Neil Weste. And there are a few more books which are available. You can search on any book and start reading the book. But before you study anything which you want to go with advanced level, you please study these topics before that. And most of these things are given in the chapter 3. only one chapter I'm asking you to read, chapter 3 of this Kang and Leblecy book. If you study only this chapter, this will help you to make the foundation of MOSFET. But I'm recommending it that you do not read it once, you read it twice, you read it thrice. You will find that you are learning on this from this chapter every day. Now let's move forward. Uh, what we did to meet the industry standards? For industry standards, we worked on Cadence Virtuoso. Uh, we studied what is the environment setup, what is the Cadence design environment, how we create library, how we use technology files, and how do we use schematic editor, how do can we can do the wiring techniques. And you will, when you start working on the Cadence, please remember that you are utilizing same software platform used by top tier semiconductor companies, Intel, Qualcomm, NVIDIA. Cadence is being used in almost every industry today. You go with Micron, you go with NXP, you go with SCL. Every company is using Cadence for the circuit designing. For everyone who want to master in semiconductor design, or you want job in this uh, physical designs, this is called backend designs, you need to master the Cadence Virtuoso. There are many other tools available. These are Synopsys and the other HSpice, other tools available, but Cadence is used in most of the companies. Then we focused on building the digital foundation. In this digital foundation, we saw that how we can go for Boolean logical expressions. We initially worked with NAND or NOR logic and mostly on the fundamental inverter. We saw from only PMOS and NMOS we used for creating this NAND or NOR. Obviously, one PMOS and one NMOS is required for inverter, but we created NAND or NOR. From this NAND or NOR, we created the complex circuits also. We created half adder. For this, we took a NAND gate. From NAND gate, we created a symbol, and from this symbol, we created a circuit for expression of half adder, and then for sum and carry. Right. So this digital, we started with inverter and we worked on these circuits. But remember, this is just a start. We need to find many. There are huge number of circuits. There is mux, there is comparator, there is flip flop, there is you call it counters, shift registers. You need to create every circuit from the very basic. So this is something that you can add on for your future tasks. Then after doing this, we scaled up the complexity. As I told you that we work with basic gates, half adder and full adders, and then we can work on them to make a multiple stages of complex logic. Transistor sizing in all the cases important. I told you that whenever you increase the width of the MOSFET, drain current increases. As our current increases, the power increases, and the power increment is not good for the circuit, but it takes to reduction in delay, which is very much required. So all these things, being an engineer, you need to take care of and keep on working on these things so that you can understand how to implement all these things. Then after doing this, we started studying the memory design, which is SRAM. In SRAM, we talked about write operation, read operation, hold state, and in this we saw that these two operations actually are the dynamic operations. So where we talk about dynamic power, this is the static operation where we talk about the static power. In memory, we called static power as leakage power also. And we started that how excess transistor and these cross coupled inverters have a delicate conflict, and we successfully simulated all three operational modes. Then after SRAM, yes, in SRAM we did two sort of analysis in Cadence. One analysis was a transient analysis, one analysis was a DC analysis. In transient analysis, we saw that this x-axis was time, and in this, the x-axis was a voltage. And in DC analysis, we saw it is very important to create the butterfly curve. This analysis is important to check whether my circuit is working correct or not. So these two analyses are required in different manner for different circuits, or for the different kind of outputs we require, or for different kind of analysis. In most of the cases, when we calculate dynamic power, we talk about the transient analysis. When we talk about the static power, or we want to talk about the stability, we take DC analysis. When we talk about the delays, again we need the transient analysis. So every analysis has its value, and these are very important. And these analysis must be matched with process corner simulations and the Monte Carlo simulations. These are very important for your publications and the other design mastery that you want in your semiconductor design. Then in this, we see that behavior using this analog design environment. Remember when we did the transient simulations? When we did the transient simulations, we talked about uh, when we did the transient simulations, we talked about the ADL only. And initially, when we started doing the Monte Carlo or the process corner at on the multiple logics, then we talked about the process corner simulation, where we talked about that this is your slow NMOS, fast PMOS, fast NMOS, fast PMOS, slow NMOS, slow PMOS, fast NMOS, slow PMOS. These all four process corners in ADL only. This process corner simulation is done in ADL, and Monte Carlo simulation is done in ADEXL. So these are two different things when we work with ADL. And most of the operations that you can do using ADL, when you start working on it, you will keep on learning that we can do a lot more things that we have done so far. Then in this, we studied about the big three performance metrics. What are the big three performance metrics we kept on talking about? One was power, second was delay, and third was area. And every circuit in digital or analog VLSI design is all about these three parameters only. Specifically in digital VLSI design, these big three performance metrics are very important. You can find out the other metrics, you can do the multiple improvements in your circuit, but without improving any of these uh, three performance metrics, you will not be able to gain attention for any of your circuit that you have designed. Then this is the description that power calculation, delay measurement. In delay, we did the basic study, like what is the TPHL, what is low to high, high to L, high to low, this propagation delay. And then how do we talk about rise time, what is the fall times, how we characterize circuit speed performance. These all about the delay measurements. When we talk about power calculation, we talk about static power, we talk about the dynamic power, we talk about the frequencies, capacitance, voltages, different parameters when we calculate the power. And when we optimize both of these parameters, then we talk that how much area we have used, or what is the overall chip cost economics, of what we have used, or what we have compromised for all these improvements. So these are the big three metrics in your digital circuit designing, and you need to take care of it. You please assume that this is a short question that you will be asked on these parameters. Then we talked about the circuit stability in SRAM. We talked about concept of static noise margins. There we talked about how much noise your device can or memory can bear, and to quantify it, we created the butterfly curve in our last lecture. We did that, the noise tolerance we saw, and how much voltage disturbance SRAM cell can withstand. Remember, this is a very important parameter in any case. Whenever you'll be working on SRAM, which is a very critical circuit, to make it robust, you need to go for this SNM. And remember, this SNM is nothing but a butterfly curve which is created from the DC analysis of inverter. So at the end, inverter is the key. When you go for the DC analysis of inverter, you definitely end up working with the butterfly curve, or the basic DC analysis of inverter is required for creating this butterfly curve. If you understand this DC analysis, then you will be able to explain or analyze this butterfly curve as well. So it is always very important to work with the base circuits and go for the complex circuits directly. What are the base circuits? Inverter is a base circuit, NAND is a base circuit, NOR is a base circuit, and these if you can work on these three, if you it's most important, the characteristics of NMOS and PMOS. If you're working on these five parameters, if you are familiar with these five parameters, if you are able to work in a good way in your cadence design on these five parameters for five topics, I repeat, one is inverter, one is NAND gate, one is NOR gate, then this NMOS and PMOS characteristics, input and output characteristics. If you are doing good on these 4 5 topics, it means you can work on any circuit digital design. It will be very easy for you to understand and learn. Then I'll say that this workshop is just the beginning. Why I'm saying so? That the skill you have acquired is cadence, but with the proficiency, CMOS design principles, the performance analysis techniques. These all techniques are highly valued in the semiconductor industries. But see, this only represents is the foundational textbook examples. You need innovation to understand. See, there are three things. One is that you will be able to recreate. This is something we expect from undergraduate level. People who are in the BTech, they should be able to recreate the circuits. When the people are in the masters, we want them to analyze, and then you build up something which is innovative in masters, either in masters or if they are very good in BTech level. Then if you are in the PhD, we ask you to conceive a new circuit and create something which is actually adding up to the current knowledge. So these are the three basic differences between the different levels. If you are at the undergraduate level, we want you to recreate the circuits. If you are a brilliant student at undergraduate level, we want you to recreate and analyze them and bring out something new out of it. If you are into a master's, you analyze, you innovate, and apply your knowledge for something good, or you will be able to find some novelty in some cases, and some cases you are not able. But in PhD, we want you to create a new circuit, devise something for your technical industry, and then add up something to the current knowledge. You achieve some objectives of your PhD, then we feel like that you have done something into your the basic what you have done in your degree. But this is not just the case that a BTech student cannot create or go for something new, cannot add up to. If you start working in your second year only, if you start working in your third year only, then coming your fourth year, you are as good as anyone to add on the something to your current knowledge. This all depends on how much effort you put on. more you work on the current this recreating the circuits, uh, once you start submitting your work to the conferences, you will start getting the confidence to publish into the Scopus or SCI index journals. Once you publish it in some good referred journal, you will feel like that you are now ready to add on something to whatever is already available. Now, what all we can do, how I can collaborate with, because I am your learning partner. I'm not a faculty. I don't consider myself as a professor. I'm still learning, and I want you to learn with me. What all we can learn together is, we can start with a few mini projects. We can go for full header. We can go for a multiplexer. We can go for a comparator. We can go for this flip flop. We can go for a counter maybe, and we can start working with on this circuits with minimum power consumption or fastest propagation delay. We do not expect initially from the undergraduates or maybe postgraduate in the initial 1 or 2 years. We do not expect you at the MTech level also to work in a huge deep dive to the literature review. You start working on the basic things only, start mini projects, and once you are done with the mini projects, say you work for the 6 months on this, then you come to the major projects and work for 6 to 8 months for your major projects. When once you work for more than 1 and 1.5 year, then we ask you to go for the literature we review, what people have done in this, and then you are now ready to think something that the people have done till this point. There is a void. I want to fill in this void. That's how you start working in the technology. Uh, at the major project level, if any of you work with the major projects and you start getting a few results, whether good or bad, doesn't matter. We will be ready to publish with IEEE conferences, and we will decide that if I can add up something to your project, and we can go for the referred journal publications also, right? Then what are the advanced research opportunities? I told you that what MTech thesis, what MTech people can work, what PhD people can work. You in PhD can define new standards for low power and high speed VLSI design techniques, and MTech people can definitely go for creating a novel architecture, whether that's improve something or not. But until it's novel, it's good that you are doing it in your postgraduate level. What are the three things on which we can work together? We can work on ultra low power design on any of your digital circuits. We can go for advanced memory architectures. I do not say that I do have specialization in creating SRAM, but yes, I have worked a lot, something more than you, in the static memory design. And then once we are done with both of these things, if you are expert in low power design, if you are expert in memory design, then we can go for beyond CMOS. We can go with FinFET, we can go with CNTFET, and other predictive technology models, so that we can create something new which will be add up to a current knowledge in VLSI. Then I want you and I request you to start your research journey today. You identify your interest, whatever interest you have, what in which field you can find your interest. You can go for the digital circuits. There I can help you. You can go for the memory designs, maybe SRAM or DRAM. There I can help you. You can go for these two with you say beyond CMOS, maybe FinFET, maybe CNTFET, maybe FE, FET, maybe I haven't worked on, but we can work together on memristors. So in all these fields, we can work together. And if you have any interest in all these topics, digital circuits, any of the digital circuit given in a digital book, you want to create it with CMOS, maybe 180 nanometer, maybe 90 nanometer, maybe 45 nanometer, maybe 32 nanometer, maybe 28 nanometer, maybe 18 nanometer. So we all can work together. And anytime you contact me, I'll be available for you, uh, depending on our mutual timings, and we'll work together on this. How you can reach out for this? You please just drop me the email with the subject, what is your research interest, what is your name, what is your topic area, what you want to do, and what in specific you look forward, what you have achieved so far. Even if you are a fresher, I'm okay with you to explain you everything, and we can start working together, no problems. And if you have worked a lot in your research so far, we can schedule a consultation so that I can explain you what you can, or I can tell you what you can do further, and how we both can contribute into your research that you have done so far, right? It is not like that I'll be doing something with you. I can suggest you people in your field, or if you just want the basic understanding of what you are doing and what you can achieve further in this, then we'll be open for a talk. That's of no problem. Maybe on phone, maybe on Google Meet. I prefer Google Meet so that we can work, we can speak face to face and can discuss the things. The rest we can decide. Then now it is open for queries, feedback, and suggestions. I have 4 5 minutes, and I want now I want everyone to please speak up. Everyone or anyone who think that you have gained something, or you want to contribute further, or you want to go ahead with it, you are most welcome. Anyone who wants to speak up, uh, these are 3 4 minutes that we can discuss. Anyone? Any
Good
suggestion?
evening, sir.
Good evening, Ajay. How are you?
I'm fine, sir. Sir, I want to provide the feedback that all the sessions were means knowledgeable, and I have gained too much of knowledge. I have clarified all my concepts from your uh, last 15 days lectures. My basics was not so strong, but now I can say I can answer anything related to these topics. And I want to work with you, sir. I need two journal papers and two conference papers per year. I want to publish. So I have published also already, but I want to publish more and more every year. You know that. So in this profession, I need to work with you. I am working on CNT FETs right now, multiple valued logic circuits. So
Ajay,
I need your
that's
help.
overwhelming. That's overwhelming to listen something from a PhD scholar. You complete your doctorate, you give your presentation, and once you are done with it, we'll definitely talk that on what mutual areas we can work together. I would be more than happy to work with you. We can definitely publish together. We can definitely go for further collaborations. I mean, whatever topic you are doing, whatever topic I'm doing, we can understand each other's. And yes, CNTFAT is a brilliant thing to do in today's era. And I have also worked a lot on CNTFAT. I do
Yes, sir.
have 7 8 publications on CNTFAT. Probably you are working on this Stanford's CNTFAT model file.
Yes, sir. Yes,
The,
sir.
the Stanford provide gate all around model files also. We can work on that also. I have worked on the characterization of it. It is in process. Once it is get published, I'll share it with you, and we'll start working with this only CNTFT and gate all around CNTFT both. Definitely agreed.
Sure, sure. Yes, sir.
Right. Thank you.
Thank you, sir.
Uh, Ajay, you please drop me an email so that I can have your email ID. And once you get done with your PhD, we'll start working together.
Sure, sure, sir. I will share.
Sure. Anyone else who wish to share, or you want to say that something that we can improve on that? Anyone else? This floor is open. You want to work on something specific? Yes, Shivansh.
Sir, actually, the sessions were very helpful, sir. Actually, I worked on cadence virtue, sir, before the workshop, but I didn't understand why we were doing transient and DC analysis. But I was doing just for the results. If
Okay.
there is a gate, we get the output. I didn't know that in deep the power and the delay. But the way you describe about things, little I came to know that why we do. So, sir, these sessions were very helpful.
You
And
Shivansh, keep on working on these things. You remain connected. When we'll work together on one complete project, maybe on memory, maybe on any digital circuit, definitely you will be able to understand that why we are doing so many kind of simulations, and how a particular simulation is important for any circuit, and why it is specific for a circuit. Right? We'll
yes,
remain
sir.
connected. We'll keep on doing a few projects that will give you the clarity.
Yes, sir.
Right? Anyone else?
Hello. Yes, sir. Very good evening.
Good evening,
I am
Dr. Sachdeva.
actually most of I just whenever you ask us to open your camera and we have a common click, so I just check it. These are all very small students, and I thought I am a faculty member. How to join this workshop? But it was actually interesting, and I never touched this subject after means during my graduation only I have touched this subject. But the way you have teach these all points with the simulation result, theoretical practical career, and you have so much energy, so thank you so much. And I will request you to conduct such more sessions, and I am always ready to attend this session. And surely we are ready for the collaboration. I am also interested to write a few more research paper along with you and your guidance. And thank you so much, sir.
Thank you,
Thank
Swatima.
you.
That's awesome to listen from the faculty member like you. I mean, uh, you gain something. Gives me a feeling that I achieved something with this. Thank you so much. Definitely, we'll work together. We'll collaborate, and we'll work on these topics in future. And I would definitely love to collaborate with you. Thank you.
Yes, thank you, sir. And you have too much patience, means the way you teach. Many times, what happens, sir, actually, the online session, when we conduct the online session, a student just muted and not listening the things. And we have that concept that teaching is only through the blackboard and something like that. But the way you have teach, it's really excellent. And thank you so much once again. Thank you.
Thank you so much, ma'am. And yes, to the point that we should work together again. And I'm planning to conduct these workshop continuously for every 6 months so that people can take advantage of it.
Yes, yes, sir. Surely. And thank you so much, sir.
Thank you, ma'am. Thanks a lot. Thanks for your feedback. Anyone else? I mean, we are just ending up with the time. I want to give you a thank you, everyone, also. So, anything else, anyone, for 1 or 2 minutes? Otherwise, I'll speak up the other things. I think we all are done. So that actually comes towards we are done with the queries and feedbacks. So it's a very thank you to everyone for joining in. I'm very thankful. You all have been very patient. You kept on asking the queries. You kept me interested in this workshop. Your feedbacks were very interesting. And if anyone has not given his feedback or her feedback yet, please submit it so that we can generate your certificates. We'll try that you get your certificates by today, or at max by tomorrow or the day after. Once we'll get approval from the university, we'll share it with you on your WhatsApps or your emails, uh, the way it is possible. My thank you to all the participants for your enthusiasm and excellent cooperation. And then I'm thankful to my department for supporting this workshop, and my thanks to my head of the department, Professor Tarun Gulati, for his guidance, support, and encouragement, because I was planning to do it in a very short way for a week. He asked me that we'll support you from this department, and you please go on for a 15-day session. And his guidance and support was definitely instrumental in this. So I'm really thankful to him also. Then here are my contact details. You can contact me anytime. I am Ashish Sachdeva. I am professor in Department of Electronics and Communication at Maharishi Markandeshwar Engineering College, which is the part of Maharishi Markandeshwar deemed to be university in Ambala. My email ID is er.ashishsachdeva@gmail.com, and contact number is 8950115050. It's also available on WhatsApp, from where I keep on messaging you. That's all from my side for today. I again want to thank you all for kept on joining, keeping me interested. And that's all from my side for this workshop till date. Let's hope that we'll meet together again in next session, probably at the end of the this next semester. I'll be planning to have a 1-week workshop on advanced level beyond these things. And second thing, I would be requesting that you please keep on working, you remain connected. You keep telling me if you have any issues or facing any issues working with the cadence. And I want every one of you to work together with me. Let's publish together. Let's flood this publications through your this IEEE publications. Let's go from conferences to transactions, and keep our institutes and our this technical fraternity interested in semiconductor field. I think I was able to somewhere to remove your hesitation from this understanding of this VLSI design. So thank you so much for everything, and let's close the session here. I'll definitely connect you everyone for your certificates, and then we'll meet together at the end of next semester. Till then, thank you so much. Goodbye, and may God bless you all.
Sir, we will keep the WhatsApp group on. Means, please don't leave the WhatsApp group or delete the WhatsApp group.
Okay. I'll
Yeah.
keep it on. Yes, right.
Yeah. Thank you so much.
Thank you. Thanks a lot. Right. Thank you, everyone. I'm closing this session for the day. Thank you. Thanks for joining.